In this video, we're going to learn how to solve problems involving proportionality reasoning, and we'll do it two ways. Okay, first we have a problem that says the speed is doubled of a ball with a fixed mass. What impact does this have on the ball's kinetic energy? So first let me write down the formula for kinetic energy. It's 1/2 mass times speed squared. And now they're saying the ball has some new kinetic energy based on new values of mass and speed. So what are those new values of mass and speed? And remember, we square the new speed value. Well, they said the mass is fixed, it's the same, like that. And they said the speed has been doubled. So it's twice the original value of speed. So if this Ke represents the original kinetic energy, m is the original mass, v is the original speed. Now, what I want to do is I want to find 1/2 mv squared in this new formula and replace it, substitute for using Ke. That's my task. I've got 1/2 already, I've got m already, but I don't have a speed squared. To get the v squared, I need to distribute the squared, the exponent, and now I have 1/2 times m times, well, 2 squared is 4, times v squared. Okay then. Now I have, you see, I have a 1/2, I have an m, and I have a v squared, so I can get rid of those things and substitute in. What do I substitute in? Ke, the original kinetic energy. And so those go away, and it becomes Ke times what's left, what remains, just this 4 right here, or 4 Ke. So what impact does it have? The kinetic energy is quadrupled, or you can just list this as your answer. Now, we just solved this using the old form that we practiced before. But what if we try to solve it using proportionalities? Here's what proportionalities do for us. They've told us that the speed is doubled, and they ask what happens to the kinetic energy. So write a proportionality down with speed and kinetic energy. What do we get? Ke is proportional to speed squared. And now we can make a little chart to figure out what's going on. If you take the speed and you multiply it by 2, times it by 2, what do you have to do to Ke? Well, the Ke changes with speed squared, so you multiply it by 2 squared, or multiply it by 4. Those are the same. And so the new kinetic energy then would be 4 times the original kinetic energy. That's kind of a shortcut, isn't it? Let me show you another example. The equation for intensity of a wave, of a spherical wave, is given by I equals p over 4 pi r squared, or sometimes that's written as an x. So what if I ask the question, when r is doubled, what happens to the intensity of the wave? We could figure this out again just using proportionalities without going through the big exercise. They're asking us about r and I. So write down the proportionality with just r and I. We have I is proportional to, this becomes a constant. 4 and pi both are constants, so those are 1. And then we have r squared on bottom. So look at what we have here. Intensity and r. The proportionality tells us how I is impacted by a change in r. Specifically, if you multiply r by 2, well, this is inverse square. Inverse square. So we're going to have to inverse square. We're going to have to multiply I by the inverse of 2 squared. In other words, we're going to have to multiply I by 1/4, or 1/4. So the new I will be 1/4 the original I, and that's the answer. Or it'll be multiplied by 1/4. What happens? It's multiplied by 1/4. Or you get the original I over 4. So what if we have a problem like this? Ball A has a kinetic energy of 5 joules. They gave us the value. B has twice the mass and 3 times the speed of ball A. What is B's kinetic energy? Well, you could solve it the old way. The KE of ball B is 1/2 its mass times its speed squared. But the mass of B is twice A's mass. And the speed of B is 3 times A's speed. When we distribute the squared, we have on the right side 1/2 times 2 times A's mass times 3 squared, which is 9, times VA squared, A's speed squared. And then we say, wait a second, 1/2 A's mass, A's speed squared, that is equal to A's kinetic energy. And instead of plugging in just KE here, we know the value, it's 5 joules. So I can come and I can say KE for ball B is going to be, well, I've got 1/2 mv squared, which is 5 joules. And then I still have a 2 that didn't go away. And I have a 9 that didn't go away. So what's that? That's 90 joules. Or you can solve it using proportionalities. Let's try that. We know the formula for kinetic energy is 1/2 mv squared. So how does kinetic energy depend on mass? They are directly proportional. How does kinetic energy depend on speed? It's a square proportionality. So let's do the two effects separate from each other. The first effect is that B has twice the mass. So we're taking the mass of B by multiplying A's mass by 2. If we multiply the mass by 2, direct proportionality says do the same thing to kinetic energy. What about this down here? If we take, so in the case it says 3 times the speed of A, so we're taking the speed, we're multiplying it by 3 times 3, but the proportionality says KE changes according to V squared, so you have to multiply by 3 squared, or 9. So what's the total change? Well, the new KE for object 2 is the original value, 5 joules, times 2, because of what happened to the mass, and then also times 3, because of what happened to the speed, and this gives a final answer which is identical, 90. So those are the two ways to solve these kinds of problems.